of the lesson today, you're gonna feel like, oh, we talked about it, right? Because I don't know if you remember on the first day I talked a little bit about right triangles. Okay? So I'm gonna review it. I'm gonna pretend that we don't know anything, and then we're gonna start from fresh. Okay? So this is trigonometry ratios in right triangles. So this is only the case of right triangles. We can't use these formulas or these equations other than in right angle triangle situation. Okay? So right triangles have a 90-degree angle. Sure. The sum of all the angles inside of the triangle equal to 180. So any triangle, no matter what it is, if you add the interior angles, it's going to add up to 180. When we label our triangle, no matter what kind of triangle it is, we always label the angles with capital letters. Okay? So we go A, B, C. For every angle, there is an opposite side, correct? So the angle C right here, it has an opposite side. We call that little c, right? Because the opposite of it is C. Angle B has an opposite side, and it's called side B. Angle A has an opposite side, and it's called side A. So the small letters, and this is where you have to be careful when you're writing. Small letters represent, or lowercase letters represent sides, and then there is a way to name the sides. It has to go with the name of the angle. They have to match. Are we okay with that?
Yeah.
Now, do you guys remember Pythagorean theorem? I know. Okay, so Pythagorean theorem is used in right angle situation, and it's used when I have two sides and I'm looking for the third. That's right. So let's say if I know just trying to figure out. So let's say this is 3 and this is 4. Okay? And I want to know what is the measure of this side. Now, because this is a right angle triangle, Pythagorean, came up with the formula that if you add the square of this bases, it's going to equal to the square of the hypotenuse. Do you guys know what's a hypotenuse? It's the line, it's the side that's across from the 90-degree angle. So this is called the hypotenuse. This does not change. It's always the hypotenuse. You should know this. This is a word that you should be familiar with.
You can call it diagonal also?
No, it's called hypotenuse.
Okay.
I know what you mean by the diagonal, but it's called the hypotenuse. Okay, because in our formulas, we're gonna always use hypotenuse. We're never gonna use diagonal. Okay, so a hypotenuse is always the side opposite to the 90-degree angle. And it's always your biggest side.
Can we use longest?
Longest, that's right. That's a better word than biggest. That's it. Pythagoras called it C. Just because he wants to stick with letter, and then he called it C. Okay? So, now the other two sides, they're the legs of the triangle. Okay? And he called them A and B. It doesn't matter which one is which. So, it came to be that C squared is equals to the sum of the square of each of the legs. So C squared is equal to A squared plus B squared. Okay? So in this case, I can find the measure of the hypotenuse because I know what A is, I know what B is. I can just plug them in and solve for C. So what's C?
3 times 5.
Because I have to square root to get to the answer. Are we okay with this? Okay, so 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. Now C squared is 25, right? But I want only C. What's the opposite of square? Square root. So when I square root both sides, right, to get rid of that square root of 25 is 5. Are we okay with that? Yeah. Alright. So, I figured out what the hypotenuse is. Okay? Now what if I have similar scenario, but instead of having, I have the hypotenuse. I'm just going to make it 2. Change this. And I want to find the third side, which is in this case, what do you want to call it? A or B?
B.
B. You guys all said B at the same time. All right. So, I know the hypotenuse, I know A, I'm looking for B. How would my formula change? So let's start with the original formula here. Or A squared plus B squared, doesn't matter. Let's just stick with this. So I'm looking for B.
C squared minus A squared equals B squared.
Plug in the values.
So isolate for B, right? So it's going to become C squared minus A squared equals B squared. Order is very important in this case, right? You have to make sure that you are bringing the right thing over. You have to make sure that you're changing your sign from a positive to a negative. Are we okay with that? If you're not okay with that, please say it now because it will happen. It will reappear. Okay. So I'm going to plug in my values now. So I know that C is 5. So 5 squared minus 2 squared equals to B squared. So that's 25 minus 4 equals to B squared.
21 is equal to B squared. B is equal to the square root of 21.
So to get rid of the square, I square root, and that would be square root of 21. You can find that on the calculator. It's going to give you a decimal. For sides, we leave it to 1 decimal place. Okay? Unless the question says otherwise. This is our rule. So, sides.
Hi.
Yes.
How do you use it on the calculator? Just 21 and the.
You have to do the square root first. So find the square root button on the calculator.
Yeah. Oh,
And
press
then
the
do
button
it.
first.
Yeah.
4.6.
Yeah.
That's all in the button.
In your case, yeah. Some calculators you have to do backwards. Some calculators you have to do backwards. So I think yours calculator is backwards. So put 21.
And that just go down and down.
That's scary then.
All right. Are we good? Do we all know how to use the square root button on the calculator? Some calculators will be a little bit backward. So if you're not getting the right answer, just call me and I'll stop. You should be getting 4.58, blah blah blah. A lot of answers just do it to 4.6 because we said it's going to be to 1 decimal.
Now, regarding square root, say
Yes.
the opposite of square is square root.
Yeah. That's right. It's like opposite of multiplication is division. Right? So this is basically the deal about Pythagorean theorem. Okay? Now you should know it. You only can use Pythagorean theorem when you have two sides are given and you're looking for the third one in a right angle triangle only case. Doesn't work for the other. Okay? Can I move back to the lesson? So the formula for the Pythagorean theorem is and then as you guys have seen, we have different versions of it. So you have the b squared equals c squared minus a squared. And let's say you're looking for a, it will be c squared minus b squared. Okay, now, in the right angle triangle, I have three sides. We all know we have the hypotenuse and then we have two other sides, right? Now the two other sides, they're going to be called opposite and adjacent. We know that the biggest and longest side, the longest side is going to be the hypotenuse. This is not going to change. Before I fill this out, I'm going to move to this and then I'll come back to this. So, and in a right angle triangle, I have a 90 degree and I have two other angles, right? So one of these angles is going to be our angle of interest or angle of focus. It's called different ways. So the angle of interest is always the angle that's given to you or the angle that you need to look for. So this is called the angle of interest because you're interested in it. So this is the angle of interest in this case because that's the one that's given to me or that's the one that's I need to look for. Now, to name the other two sides, I have to name them opposite or adjacent. Okay, hypotenuse, the first thing that you're going to name, you're going to say, okay, this is H because that's my longest side and that's the one across from the 90 degree. Period, done, let's move on. Okay? Now, angle of interest, which side is opposite to it?
Oh.
is the O, right? That's why it's called an O, because that's the opposite side of the angle of interest. Then you have one more name, which is the adjacent, and that goes to the third side, which is always going to be touching the angle of interest. Okay, so this is called the adjacent. Okay? Now, if the angle of interest changes, and now my angle of interest is the top one, right? As you can see, my hypotenuse doesn't change, it's still the same. Now, which side is your opposite side? The bottom one, which is this one. And then this is going to become my adjacent. When you get a right triangle, the first thing you want to do, locate your angle of interest, which is either the angle given to you or the angle that is that you're looking for. Then label your triangle. You want to label it with A, adjacent, opposite, and hypotenuse. Start with the hypotenuse, move to the opposite, go to the adjacent after. Is that clear? Now the reason we call them this way is because there is the primary trigonometric ratios. So that's a mouthful mathematical term. Primary trigonometric ratio. The primary trigonometric ratio are called sine, cosine, and tan. These are the ones that we use to solve our triangle. Okay? So they figured out, after they did a lot of testing, they did a lot of algebra, they figured that if I have two triangles, right triangles, okay, they're similar triangles, so that means they have the same angles, let's say. So this angle is the same as this, and this angle is the same as this. Okay? They figured that if I do sine of the angle, it's going to equal to the ratio of the opposite over the hypotenuse. Okay? So let's say this is angle 30. Okay? They figured that if they do opposite over hypotenuse for that angle, and opposite over hypotenuse for this angle using these triangles, they're getting exactly the same answer. So they came up with the idea that sine of angle 30 is opposite over hypotenuse. Okay? No matter how big or small the triangle, sine of 30 is going to be the ratio of your opposite over your hypotenuse. It's going to give you exactly the same. Now, if you're interested in knowing how they got to this and then how they did the math, I can send you a video. We did that in grade 11, right? It wasn't fun. But the whole idea of it is that you understand that sine, cosine, and tan, they're ratios. So that means the side over the other side. Okay? All what I want you to now focus on, if you want, I can find a video and send it to you. But what I want you to know for the purpose of this course is the formulas, SOHCAHTOA. Okay? So sine, what letter is this? So that's angle, what is it called? What is that letter called? It's a Greek letter. No? Someone can guess that? Yeah. Theta. It's called theta. It's a Greek letter. So they use it to indicate an angle. They like to use Greek letters a lot, especially with angles. Okay? So that sine angle theta is equal to the ratio of the opposite over the hypotenuse. And this is where so comes from. Sine, opposite, hypotenuse. So. Can you guess what ka represents? Yep. Okay. plus So if you can't remember the acronym SOHCAHTOA, you should be able to remember the formulas. Tan, what do you think it is? Okay, can you guys locate sine, cosine, and tan on your calculator, please? Sine, cosine, and tan, they always come with an angle. So you can see that sine something, that something is an angle, okay? Cosine something, so that's gonna be an angle, either angle 20, 25, 31, 51, 62, right? It's whatever that angle is. Are you okay with this?
No, you know, my mind is going to A for sailing. I little learned. There were
And you're gonna do a whole unit.
There are some things, you know, angular velocity is small w.
Yep.
In that, you know, cos theta was there. That troubled me so much in my life.
Yeah. So there's like theta, there's alpha, there's beta. We use all these letters, and they actually they represent angles, right? So alpha would be like this. Beta would be like a big B, but with a little longer tail. So if you see these Greek letters, they just represent. It's a name. It's a instead of calling them A, B, C, they call them alpha, beta, beta.
In our country, you know, to Greek, people say Greece.
Greece, yes. That's French. Okay. So what do you need to be able to use SOHCAHTOA? You need always, one side and one angle other than your 90 degrees. At least. One side, one angle. Or two sides and you're looking for another angle, right? So these are, if you're looking for the side, then you can use Pythagoras, right? So one side, one angle, you're looking for another side, or two sides and you're looking for an angle. We're gonna look at examples, how to do them, how to get to the answer. All right? Now, these are the steps basically that you need to follow to solve. First thing, you're gonna label your triangle, right? With your opposite adjacent hypotenuse according to the angle of interest. You're gonna then see, okay, I have an angle, I know the opposite, I'm looking for the hypotenuse. Which SOHCAHTOA I'm going to use? This is what you're gonna be asking yourself, okay? You're gonna keep asking these questions to yourself so you know which ratio you're going to use. You're gonna write the formula, substitute numbers in, solve, and then round length to the nearest tenth, which means 1 decimal. Let's look at an example. So, I have a right angle triangle. The question is telling me that to find a measure of side P, knowing that angle P is 60 degrees. So where's angle P? Angle P is right at the bottom. Where's side P? And good. Yes.
Okay, so the angles are given.
Yeah.
And we already know that's a 90 degree right there.
Yeah.
But 60 couldn't be at M because it says for P.
It says angle P is 60. Okay? I know an angle and I know a side, right? Angle and side. I'm looking for another side. Okay? So let's name the triangle. Let's name the opposite adjacent hypotenuse. It's MP, right? It's MP, that's the hypotenuse.
The angle of interest P, the opposite.
Where's your opposite?
P.
MN or P. Yep.
And
60. I'm looking for which side? Opposite, adjacent, or hypotenuse? Yes. I'm looking for P, right? So I'm looking for the opposite. Okay? I know which one.
Hypotenuse.
Hypotenuse. So I have to look for something with opposite and hypotenuse.
Because it's on, yeah, it's on, that's what it's in.
So it's sine. Right? Because opposite and hypotenuse. So sine P equals to opposite over hypotenuse. What's P? Yep. Opposite, I don't know. Over hypotenuse, which is 220. So, I labeled my triangle. I wrote the formula. I chose the formula that I want. I plugged it in. Plugged in the information, give it to me. Now I have to solve for the opposites. What do I do?
You have to get opposite by itself, right? On one side. You know what I'm saying?
Isolate for the opposite. How do I isolate for the opposite?
So
Cross multiply. So it's going to be 225 times sine 60. So when you're doing this on the calculator, you want to do 225 times sine 60. Don't do sine 60 times 225 because that might get the calculator confused.
195?
So you want to do 225?
Times sine 60, so that is 9190.8. What's after 8?
194.86.
So that becomes sine. So if you want to write down, no, it's fine. That's fine. Yeah, that's the same thing.
Yeah.
Are we okay with this? So it must be to one decimal place, so it was 194.85. I have to round it up to 9. Now you have to make sure that your calculator is in degree, because if your calculator is not in degree, so it usually says on the top DG, it says D, right? If it doesn't say anything, that's also fine. But if it says anything like RAD or R or radian, that's tough. Sometimes it doesn't say anything, which is fine. It doesn't say anything. It doesn't say DG.
Oh, like that.
No, your calculator is fine. Your calculator will not. Do you have another one?
It's hard to open.
It's hard to open. Can I have it? Can I just-
And then the agreements at the top here.
Okay. So look at the next one and do the question. Angle C is your right angle. Let me just do this for a second, so I can stop this.